So there's a lot of properties here, and I'm not going to go through and prove all of them. That would get very boring, but I am going to prove a couple of them so you can see how proofs work with these. All right. So let's start with A here. I want to prove that u dot v and v dot u are the same thing, that they are equal. So I'm going to work on A here, and I'm going to construct a proof. As usual, when writing a proof, it's a good idea to start your proof writing with the word proof. That way everyone knows what you're working on. Okay, we're going to use complete sentences when we write this proof. Capital letters at the beginning of our sentence, periods at the end, and it's best not to start your sentences with symbols. Do not start any sentence with a symbol. Start your sentence with a word. Okay. So first, I have two vectors u and v. I want these to be expressed in component form so that I can actually perform the dot product. So let's let vector u be the vector with components u1, u2, all the way to un. I know I want to go to un because vectors u and v are n-dimensional vectors, so they're going to have n components. And similarly, let's let vector v be a vector with components v1, v2, vn. So I'm working with the components of the vectors. I'm going to the definition of what a vector is. So just to clarify, u1, u2, all the way to un, these are just numbers, right? These are just numbers that are the components of vector u. Same for v1, v2, all the way down to vn. Just numbers that are the components of vector v. So now, what I like to do when I want to show two things are equal, I'm going to first start with the left side, simplify it as much as I can, then work on the right side, simplify it as much as I can, and then show that they are equal. Okay, so let's first do u dot v. First, observe u dot v is equal to, so vector u is u1, u2, all the way to un. And I'm going to take the dot product of that with vector v, which is v1, v2, all the way to vn. And now I'm actually going to write out what the dot product is. We know the dot product from the definition. All I'm going to do is multiply corresponding components. So u1, v1, u2, v2, and I'm going to keep going until I've multiplied the last corresponding components, un, vn, and then I just add it all together. And that's the dot product. So I'm just going to end my sentence with a period. Okay, so I've done the left-hand side of the equation. Now let's do the right-hand side of the equation. So the right-hand side is v dot u. So v dot u, and same thing, I'm just going to plug in what u and v are. So v is v1, v2, all the way to vn. Dotted with u, u1, u2, all the way to un. And if I take the dot product, same thing. I multiply corresponding components and add them together. So I get v1 times u1 plus v2 times u2, and I keep on going until I add the last product of corresponding components, vn times un. Okay, and I'm going to take a breath for a moment and take a look at what I have. This is the left-hand side of the equation. This is the right-hand side. I want them to be equal. So is there any way I can get this and this to be equal? Well, they're almost there already, right? The first term here is u1, v1. The first term here is v1, u1. Are those the same? Well, yeah. Because u1 and v1, they're just numbers. And I know for plain old ordinary numbers, not vectors, but for numbers, commutativity holds. So if I have 2 times 3, it's the same as 3 times 2. Maybe I shouldn't use the dot to avoid confusion. But if I get 2 times 3, it's the same as 3 times 2. So u1 times v1 is the same as v1 times u1. And the same is true for the second term. u2 v2 and v2 u2 are the same thing. They will calculate to the same thing because multiplication between numbers is commutative. So I can rewrite v2 u2 as u2 times v2. And I could keep doing that until the very end. Vn times un is the same as un times vn. And I'm done with the sentence, so I put a little period there. And now look, u dot v is equal to u1 v1 plus u2 v2 plus dot 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 plus un vn, and that's exactly what v dot u is equal to. And so since they're equal to the same thing, they must also be equal to each other. Therefore, vector u dot vector v must be equal to vector v dotted with vector u. And that's what we wanted to prove, so we're done. When we're done with the proof, we put that little box at the end.